So, hello and welcome to the Bitcoin meetup. I think it's, I can't count them anymore, and it's also our third, I guess, meetup specifically about the Lightning Network. It's one of the hottest topics, I guess, and it will surely not be the last one. We have a special guest, Tank from Lightning Labs, who will introduce the Lightning app wallet that he was programming, and we will also go after break. We will also go more deeper into the protocol. Rene will do this talk then, but it will be very technical. So maybe after the break we will see how. I mean, you can just take a relax and take a drink in the break, and then maybe you will be able to follow this talk, and maybe we can do something else then. So, I also have to thank, of course, this great location here, and thanks for the drinks and the pizza. Mark is our host from Blockchain Consulting, and he will tell you a few words about this place here.
Super excited having you all here. Hosting the Bitcoin meetup was a dream for a lot of us. Over the last years, we grew to 2014 and grew over that time. And since then, we regularly attended the Bitcoin meetup, and we're absolutely astonished at how big it got. And so it's really great to see so many faces. And yeah, we're glad to give you some pizzas and the opportunity to watch brilliant talks. Since we're also doing blockchain technology, we're always looking for experts, people that want to be experts or people that have experience in that field. If you want to contribute to blockchain projects or develop software that on the protocol, then please feel free to talk to any of the guys with these shirts here who want to talk to you. And without I skip the rest of the boring part, so please let's hear Tankred with your talk.
Thank you. All right, this is really cool. There's like 100 people that came. Like, I just wanted to demo the app, and now we have a live stream and everything. I think somebody flew in from Bologna. That's crazy. So thanks for coming and taking the time. So what I'd like to present today is kind of like the result of a 6-month effort. We had a very early prototype of the Lightning wallet, but we kind of tried to completely redesign it. And not only the wallet, but also we thought about, what would the Bitcoin payment experience be like? Right now, Bitcoin's being used as a store of value, but it's not really being used as a medium of exchange yet. So we were thinking, like, what would that be like? So it's kind of a very aspirational user experience. But we feel like that's where it could go in the future. So just to start off, so who here knows what the Lightning Network is? Okay, awesome. Seems like a very knowledgeable crowd. And so who thinks they have like a fairly rough understanding how it works? All right, cool. Who has no idea who thinks Lightning is an ICO? Awesome. Okay, cool. So, I mean, Rene is going to be kind of diving into the protocol layer. I will kind of keep it very high level. But in a nutshell, Lightning is a layer 2 scaling solution for Bitcoin. There's multiple solutions in the space right now being developed, and Lightning is one of them. So the idea is that you don't need to broadcast every transaction to the blockchain, right? You don't need to broadcast every coffee or small transaction that you buy. The metaphor that we always use is like a Lightning payment is kind of like a contract, and you can enforce that contract if you go to court, but you don't need to enforce every contract at a court, right? And the same thing is with the Lightning transactions. So payments happen peer-to-peer with bidirectional payment channels. the transaction are off-chain, and you can do multi-hop routing. And one of the last points are very important for the security aspects of it. Right now, a lot of people are holding their Bitcoin in cold storage, and with Lightning, with a wallet at least, those are in hot wallets, right? But I mean, that's all a bunch of technical mumbo jumbo. You know, what does this all mean for the user? You know, this is obviously only going to take off if it's understandable. So this is what we're trying to do. From a user's perspective, we'd like Lightning to be kind of their checkings account, right? So you have their savings account for your cold storage savings, and then you have a Lightning as kind of your checkings account, right? You don't put too much money into that account, and whenever it's empty, you fill it up again. I think that's kind of the abstraction that we'd like users to have. And yeah, do a brief demo of that. All right, so the first thing you'll notice here is this might look a little bit different than most Bitcoin wallets, right? So it's a little bit cleaner. It might kind of resemble something more like maybe like a PayPal, you know, like request pay. And obviously this is not real Bitcoin. This is test Bitcoin. We're on testnet right now, so I don't have thousands of dollars on my computer. But yeah, so like as a user, what you can do basically, you can fund this wallet, you can send some Bitcoin there, and you can copy that address, right? We have a channels page. So right now, channels is very kind of, it's a concept that right now users still have to understand because the technology isn't as mature yet. But over time, we'd actually like this page to kind of fade away into the background and kind of be more here in the advanced settings. So as the network matures, as the technology gets more reliable, we'd actually just like this to kind of just be a little less prominent, right? And to kind of demonstrate how a normal Bitcoin payment would work, like, so what you do here, you go basically to the payment screen. And right now, I actually copied my own address. So what I'll do here, I'll just paste that. And then what happens is the color changes. So this is kind of to indicate that, you know, careful, you're going to do an on-chain transaction that has some trade-offs. That's going to be take a bit longer to confirm, and there's going to be some fees. So I'm just going to send myself some Bitcoin. This is being displayed in fiat because I just have fiat, but you can also display this in BTC. And you know, that's it, right? So that's kind of the on-chain transaction. Now, if we kind of look at like, okay, let's imagine we have a vendor here. You know, this is like an online shop. This is actually y'all's, a really cool demo site. So, and they have a bunch of things that we can buy. And, you know, we could obviously go here and also kind of paste the Lightning invoice. But what we're going to do right now, we're just going to, I don't know, take this guy, because he's super cool. And we're just going to press on that link. And then what that link does, it just opens a confirmation. And this basically is the kind of the invoice, the payment request. So all I have to do, okay, right, this is one thing. And this costs 1 cent. But I guess in general, what we should like take a minute to actually appreciate here is, I think in the Bitcoin space, we kind of take for granted what's going on here. But it's kind of cool. Like, I have kind of a provider that's offering something in US dollars. You know, I have a local wallet, and it's displaying euros. And I'm not paying any fees, you know? And that's like, that's pretty cool, you know? And the payment is instant. And especially for people who travel a lot, you might like need to settle costs with a friend. That friend might not have a European bank account. That's a pretty cool value proposition. So this is the kind of the experience that we kind of imagine users to kind of engage with. And obviously this is a very early version. This is going to be the first alpha version. So this is just going to be kind of the beginning of a conversation with the user to learn more about requirements and see where this whole thing is headed. Yeah, so let's get back to the slides. I'm really glad that worked out. The demo gods were good with me. Cool. All right. So obviously, this has a lot of implications in terms of like security and user experience. So there's a lot of stuff going under the hood, and we just want to make sure that this is something that an average user can grasp, right? Right now, the technology isn't really mature yet. It's going to need some time to mature. So there's stuff like channels, which are still being surfaced. But we hope that over time, this will get easier to use. But in terms of security, there's obviously a lot of new, like in the security space, people say foot gun potential. So there's potential for users to shoot themselves in the foot. Because you're now no longer putting your Bitcoin in cold storage, you're going to put them on a device, and that device maybe is susceptible to some attack surfaces. And what we kind of want to do with this user experience is we want to nudge the user in the right direction. You know, we want to offer something that's secure, but that's also easy to use. So this is kind of I guess our main job as developers. And I see this a lot in the security space. So before this, I was working on email encryption. And there's, in the security space, you have a lot of like technical people, a lot of security-minded people who like want the right things, but are oftentimes like, I guess, sometimes making like trade-offs which aren't really in favor of the user. So I think as developers, it's our job to facilitate a culture of empathy for the user, Try to be open-minded, try to think about trade-offs, like, and try to not basically try to listen more, right? So when you think about like the cryptography UX of like systems like PGP, email encryption, it used to be that people would go to like crypto parties, they would teach people how to use these tools, and it turns out this doesn't really scale. Like people don't need to be taught how to use apps, right? So what we need to do, instead of teaching people, we need to build usable protocols and apps. And this is what we're trying to do with the Lightning app. We're trying to like learn about what the user experience should be to inform protocol design over time, and yeah, just learn things. And one of the things that's obviously often said about developers, security developers, is they might be susceptible to security nihilism. So the security nihilism, this is from Alex Stamos at Black Hat 2017. His point was that, so security nihilism is an overlapping set of beliefs that includes the assumption that all attackers are perfect, that everybody faces the worst possible threat scenario, or that any compromise to make a security feature more widespread should be considered a bug. And what he's trying to say here is that the industry, the InfoSec industry in particular in this case, is kind of suffering from this state of mind where we're not always making the right trade-offs. We're not always understanding the user. And sometimes it's okay to make trade-offs. So here's some of the ways we try to make things a little bit easier for the user. One thing that might be pretty obvious, but not always the case, is like we just use plain English, right? So in this case, this is the recovery seed that you need to use to recover your wallet in case you lose your device. And here we're using the wording a recovery phrase. Ledger's actually also using the same wording. And I think Apple is using the wording recovery key if you have an Apple account. So this is something that users might be comfortable with. They might know what's going on. And we just try to explain to them in plain English. Here, we're basically reinforcing a double check of the seed. So like just like with a random order, just kind of confirm that you've written down the seed. Also very much a best practice in the industry. This is part of the kind of onboarding process. So the first time you start the app, you write down your seed, and then we kind of give you kind of a screen where you can fund your wallet, put some first Bitcoin into it. And we see this as a nice little guide along the way. And this screen kind of comes up the first time you open the channel screen. We try to explain to the user that actually the Autopilot feature is opening channels for them, right? So we don't want, like I said, in the mid to long term, we actually don't want users to be, like most users to be exposed to the channels at all. So we'd like that to kind of fade away. But in the beginning, users might go to this page and they might kind of ask themselves what they need to do. And here, they're kind of being told, all right, you might just need to wait a little bit, right? And then obviously, this one thing that all current Lightning implementations do is that they limit the funds per channel. So in this case, I'm just displaying it in fiat, but all the channel funds are currently capped. Also, one thing that we try to do is at least hide all the technical details and submenus. So if advanced users are looking for, I guess, like the public key, or are looking for transaction ID, all these things, they can find them, but they're going to need to look, right, in a third or second hierarchy. And this is what I showed. Basically, the payment workflow is such that you can copy and paste a Bitcoin address or an invoice, and the app just kind of does the right thing for you. And also giving clear visual cues. So making sure that the user is aware that he's actually not doing a Lightning payment in this case, that's going to have the trade-offs of an on-chain transaction. And obviously also in terms of, I mean, this is a very simple security measure, but just having the user confirm, right? Giving him a chance to kind of look at what's going on. And we have a note so that the invoice specification has a description in it. So the vendor, in this case it was Starblocks, they have like a kind of a blockchain demo site. I'm paying for 1 blockachino. All right, cool. So that's kind of I guess the UX part of the talk. Now we're going to kind of look at a little bit at the security and the architecture. So the desktop app is written with Electron, and the user interface part of it is written in JavaScript and React Native. And we do this because we basically want to, like you might have noticed the UI is very mobile-centric. So we're doing this because we want to reuse a lot of that logic for mobile. And the protocol layer is LND. So if you already maybe tested LND, you already have a node deployed on the CLI, you're probably going to be very familiar with it. We're kind of using it as a library instead of a daemon in this case. And it runs in its own child process. And so basically what happens here is the child process talks with the main process over a gRPC, and then with the rendering process over IPC. And obviously, Electron isn't known for its security, so there's a lot of potential attack surfaces that we need to mitigate. And here's just like, it's not an exhaustive list, but I think it's the beginning of kind of a conversation around security, so we could at least like scope the threat model. And I'm going to go through all of these one by one. So I guess the easiest kind of threat model to think of is that if your device is lost or stolen, right? What if you have like some Bitcoin on there? And like the easiest way to mitigate this is obviously the user should have a seed backup written down somewhere so he can restore his wallet. The wallet is currently encrypted on disk. So when you start the app the first time, you need to input your password. And we currently don't do this because we haven't implemented the seed restore feature yet. But one thing we might think about doing is actually encouraging the user to transfer his funds. If he thinks that his device may have been stolen, it might be a good idea to actually move his funds to another device. Phishing and transaction spoofing. So one of the things that the app currently does is actually sanitizing when I clicked on the link, that opens the invoice. So what the app does, it sanitizes that, makes sure that everything's okay. Another thing that we will probably do in the future is actually cap that. So if there's a really big amount, maybe display a warning to the user. Are you sure like this is what you want to do? But I guess for smaller transaction, it might not be as important. One extra step the user needs to do is the first time the app opens the app, he needs to unlock it, and then he obviously needs to confirm the transaction. One thing that's very common, obviously, on laptop computers is malware. So on a Windows or Mac, you might have some kind of malware. This is obviously why a lot of people use hardware wallets. But in this case, like we can still mitigate some of these risks, right? We can still limit the funds per device. We can still recommend the user use like something like a Chromebook, which has hardware-based security, so something like a trusted platform module. And Chromebooks are probably some of the most secure, I guess, consumer notebooks out there. Or something like iOS, something with an OS that has some strong sandboxing. Something that's obviously out of scope for our threat model in software is root level access or physical access to the device. So let's say you have an evil roommate that installs a keylogger. Like obviously this is very difficult to mitigate in software, and we would need a hardware wallet support for this. Since we're also basically building this application in JavaScript, I don't know if you guys follow like the news around JavaScript. There was, last week I think, there was a vulnerability where somebody published a malicious ESLint package. ESLint is like a linting tool kind of used in probably every modern JavaScript project. And this actually read the user's credential from their computer. So a way to mitigate against this is several things. So you need to lock the dependencies in the package JSON. So each of the dependencies are verified with a SHA hash. And also GitHub has some really cool features. They actually notify repository owners if one of their projects is using a package that's vulnerable. So we're also using that. And last but not least, the app uses auto-update. So this way, like even if there were to be a vulnerability, like in Electron or in one of our dependencies, we can at least keep the vulnerability window small. This is something that happened to the Signal Messenger app recently. They had a cross-site scripting attack in the rendering process. And there's several things you can actually do in this case. So one thing that we do is we run LND in the child process. So LND actually holds the user's private key, and this is never surfaced to the rendering process. So the private key of the wallet never leaves LND, the LND process. We also escape all the strings. React actually does this out of the box if you use it correctly. We also set a pretty strict content security policy. So this is something where you tell the browser or the rendering engine, you know, don't execute any inline script that you come across. If an adversary would try to do XSS and try to inject some inline script, the application would just not execute that. We also disable node APIs. So this is one of the really big pitfalls of Electron. Like by default, the developer experience is pretty poor because most developers might not even know that it's a bad idea to have node APIs in the rendering process, because any XSS attack would instantly get access to the file system. So we disable those. We also activate the Chromium sandbox. So Electron is based on Chromium, and you can activate that sandbox of the rendering process. And we also go further to actually remove the direct IPC API layer from the rendering process, and we actually whitelist only the APIs that we need. Some general, I guess, web app security best practices that anybody who's doing this type of work might be aware of. So don't use the bad parts of JavaScript, right? JavaScript is a historically grown language. It has a lot of warts, like most historically grown technologies. So just don't use the bad parts, use the good parts. And one of the ways you can enforce that is that you can use ES strict mode, which has been in the browser since ECMAScript 5. So you, don't use eval, don't use inner HTML, all these features. You can sandbox untrusted content in iframes. You should always have high unit test coverage. Do peer review to kind of get a second set of eyes on the code. And also what's really helpful, if you have the budget and the threat model justifies it, you should do a third-party security audit. All right, so you might be asking, I don't care about all this. Like, when can I get this on mainnet? So the app is going to be launched very soon. So we're going to, right now it's still pre-release because we're kind of still ironing out some bugs. But we're planning to launch this very soon, and it's going to be on testnet, and it's going to keep the alpha label until we feel like it's safe enough and mature enough to go to mainnet. LND itself is actually already on mainnet, but we want to make sure, like, because we're exposing a lot more users to this, that we just want to make sure that it's safe. And the alpha release will align with Neutrino in LND 05. The app will run in light client mode by default, so you don't need to run a full node if you don't want to. But if you do want to, and you have the technical expertise to do that, you can just run a full node and connect the app via RPC. And so the code has been open source since day one. You can just check that out. You can already try it in full node mode. You just can't run it without the RPC flags yet because Neutrino isn't working yet. Yeah, so what are we working on next? So this is kind of going to be the iOS design that we're working towards. Obviously, the cool thing is because we're building everything with React Native and with Go, there's a lot of code reuse there, which is great. And this is going to be kind of our next step. And with that, some shameless advertisement. If anybody's interested, I'd love to talk to any experienced React Native developers that are passionate about Bitcoin. All right, that's it. Thank you. Yes?
What do you do in case your app is offline for a long time and the channel is closed with an old state?
Without state?
With an old state. So the other side of the channel closes with more money than actually should be in the channel at the moment, at the site.
Okay, so yeah. So the question was, what happens if the other side, did I understand correctly, they broadcast an old transaction? Okay. Yeah. So we're working on something called watchtowers, which basically, if you're using this application on like a mobile device, which isn't always online, like if you're using it basically, if you're running it on a server that's always online, that's not an issue. But if you have your device in your pocket and you kind of maybe go online once a month, once a week. So Connor on our team is actually working on this, and this basically assures that you don't have to keep your device online all the time. Having said that, I'm not a protocol developer, so I'm probably not the best person to ask this. Rene might actually be a better candidate to ask this stuff. Yes?
We're talking a lot about the UX of sending the transactions, and it looks really awesome. It's on the website and it instantly loads into the wallet and all of this. What about the user experience of creating and closing channels and allocating money into channels?
Yes.
Allocating your funds between your cold wallet and your Lightning wallet.
Yeah.
I think that's a really difficult new part for people to understand.
Yeah, sorry if I didn't make that clear. So the app comes with a feature called Autopilot. Oh, I'm sorry. So the question was, what happens, what about the user experience of opening channels? That's pretty technical. That might be a little bit too difficult for the average user. So the application comes with a feature called Autopilot. So what this does, it kind of, in the beginning of the onboarding process, I didn't show this because in the sake of time, it would take 10 minutes for one confirmation. But when you have enough confirmations for your on-chain transaction to fund your wallet, what Autopilot actually starts doing is opening channels for you. So it just does it automatically. It just finds 5 peers and it connects to them. And then in the best of case, you can just transact. I mean, we're very aware of the fact that there's still, the network isn't as mature as we want it to be, right? It's still early days. And Autopilot might not find the best nodes yet. But over time, I think once we get to a point where routing nodes have better availability, better uptime, better liquidity, and we've kind of fleshed out the heuristics about how we connect to which routing nodes, this will kind of become more important. And this is what I meant with over time the channels page will just move to the advanced settings, right? We don't even want users to worry about it.
Is there some way for the user to decide how big of a fee he is willing to pay to open the channel? Or is it going to be in the settings of the app that you can adjust your auto
That's a good question. So the question was, can I select the fee when I open a channel, the on-chain fee? Currently, no. So what LND does, it does like an estimate of the fee, on-chain estimate, and it kind of just opens the channel for you. It assumes that it's going to make a pretty good estimate.
But do you want to put that in the UX of the app, that the user is able to say maximum 3,000 Satoshi fee for opening a channel, or do you give no input to the user, no ability to change the settings?
Yeah, so the question was, do we want to expose that in the UI? No. So I mean, obviously, different apps have different goals, right? You could have a goal which is you could have an app which is more geared towards the advanced power user, you know, like the experienced Bitcoiner. This app is kind of very aspirational in the sense that we want to make it more accessible to more users, and for us, it's also kind of a proof of concept if it's even impossible. You know what I mean? So we're still learning, and we feel there's a lot of value from having something more accessible at this point. Sure.
Are you working on something to mitigate the weird feeling, the uncomfortable feeling you have when you are copying something, the address in the app?
That's
Every time I do it, I go back and forth between the other windows to see I've copied the exact address.
yeah.
And so that's probably if you want to have a service that is supporting everyone.
Yeah, that's a good question. So the question was, how do we, or can we mitigate if somebody copies and pastes an address? You know, what if somebody man in the middle attacks that potentially? How do we let the user verify? So the answer is that's really hard to verify without a hardware wallet. Because in a hardware wallet, I just don't trust anything that happens on my screen. I just look at the wallet and confirm the address there. Because that's like the lowest attack surface possible. Obviously, for a desktop application, you have limited possibilities, right? And this is one of the trade-offs that our application makes. It kind of, because the use case here isn't like I'm sending hundreds of thousands of dollars or like tens of thousands of dollars. I'm sending like I'm paying for a beer, you know. The possible, I guess, the possible attack vector or the possible attack surface for the user is minimal. So our assumption is that it's okay to make that trade-off. Yes?
So I already tried some Lightning wallets on mobile, and I always have the same problem. Whenever I started the wallet and funded the wallet from Bitcoin and channels, I always have to spend money first to be able to receive money.
Yes.
And I see you have the same problem at your screenshot. You have a lot of open channels, but like zero receive balance. So how is this going to be solved?
That's a good question. Thank you for that question. So the question was, what about inbound liquidity, right? Right now, when I fund my channel, I have a lot of outbound liquidity, so I can send payments, which kind of addresses the the Visa use case where I'm basically doing commerce. But what about if I want to the PayPal use case? I want my friend that I just want to settle costs with during travel. How do I get money from him? And the answer is, so there's possible solutions there. One is obviously you pay somebody to get inbound liquidity. Another solution could be obviously you've already have enough history there. But that's something where I'm probably also not the best person to ask, given that, yeah?
So, like really solution that comes quickly to my mind is that my friend opens a channel to me and I open a channel to my friend. So is this currently possible on mobile? So is your node reachable through the network? Because you're behind a nut and can I just give a friend my node ID or whatever this is and he opens a channel to me? Does it work?
Okay, so the question was like, what if I'm on my mobile device and how can somebody see my IP address? Can they create a channel towards me directly? The answer is users shouldn't even need to worry about that. What we want to get to is a place where the routing node infrastructure is so mature that you don't need to do that. You know, you just like ideally that inbound liquidity problem is already solved because we've already like have mature infrastructure in place, and you just send somebody a payment just like you do in PayPal. But obviously we're not there yet. Like it's early days, right? All right. Yes.
How confident are you that you will get this on the Apple App Store, as Apple is very reluctant now on crypto-related apps?
Yeah, that's also a good question. So we actually, we already saw that there was actually already a Lightning wallet that got accepted to the Apple, iOS App Store. And Apple actually specifically has some new terms of service, specifically for cryptocurrency apps. So I think they don't allow you to advertise ICOs, you know, anything scammy, obviously. But if you're just doing a wallet application, they actually specifically allow that within the terms of service. Okay. Yeah, I'd love to hear about it later, but. Okay. Yeah.
The general part about it, it's the same with cryptocurrency ads on Facebook and Twitter right now, is they ban everything in the first page, but they're slowly opening it up again. But you need to go to a very strict verification process. So you really need to fill yourself out and have everything ready and feel it shit to actually get your ads out there. And I think it's the same with the App Store.
All right.
I just want to shortly touch base on the user experience side, which is one of the major sides, actually getting all those users using Bitcoin in general, and one of the hugest challenges. And bringing out a product in any sense on an app store, on the web, is having some kind of customer service with it. People expect some kind of problem solving ASAP if something's not working, especially if my money isn't. And knowing that from your slide with everybody or the power users have their coins on the cold wallets, I think we know that most of the people got their coins on some exchanges, don't even bother to use some random apps or wallets. And coming from that, how do we, or if you have some insight, how do we give them information so they know what's going on? I've withdrawn coins from this exchange, but they're not arriving in my wallet. What's happening? I'm blaming you. What is wrong with your wallet?
Yeah.
I'm not getting my coins. Do you have any insight on how to mitigate this? How to get more information to the people without confusing them, without overloading them?
No.
Not in the first step, I suppose. But
So let me repeat the question for the live stream. So the question.
this is like the security and the accessibility problem, right? You have to take something from each of it, but you can't have both at the same time.
Yeah. So the question was like, obviously there's gaining traction problem. How do we get these users to install this thing in the first place? You know, consumers have very high expectations. They're just using right now keeping their Bitcoin on exchanges, right? What do we do if one of those users blames us if they lose some Bitcoin? And these are all great questions. And I mean, like obviously we haven't shipped the product yet, right? So this is everything we're going to have to learn, you know, and we're very open about learning all of that. But I think it's something that is a general problem for the space, you know, like you are your own bank. There's no throat to choke. So that's I think I agree. That's probably the biggest like mental barrier when I talk to people who have never like thought about Bitcoin, and they're like, okay, that's crazy, because everybody's used to putting their money somewhere in a safe place with somebody that they trust, right? And this is different with Bitcoin, right? So obviously, we hope that exchanges integrate Lightning, and we hope that there are services that are custodial that make it easier, kind of for the first-time users. But this is obviously an application that tries to do something different. The problem we're trying to solve is not like that user. I think that user is fine with using a custodial service for now, right? Until he learns about the trade-offs and risks of that. There's obviously also a risk if I keep my money on an exchange, right? it might be safer for some users actually, because they might like not understand the whole wallet backup and that. So, but I mean, you obviously, when you're building a product, you need to make decisions and emphasize certain product, I guess, categories, and you can't solve all of them.
Follow-up question.
Yeah.
Having the question earlier on funding a tunnel before I can actually use it, do you think that exchanges or huge platforms that already amassed a huge amount of coins will do that for the user and thus centralize also the Lightning Network as it's with the mining cartels?
That's a good question. So the question was, what happens if big companies that own a lot of Bitcoin, they will put all their Bitcoin in hot wallets and kind of centralize the Lightning wallets so that they're basically becoming this Uber routing node. And the question, and the answer is very simple. If they do that, they offer huge attack surface, right? And like if you put a lot of your funds in a single point of failure, like you're inviting attackers, right? And the honeypot is really big. So, and this kind of creates incentives for decentralized routing, right? And this is really great because we don't want the Lightning Network to be centralized, right? We want that risk to be spread out around the network.
Good answer, thank you.
Yeah. Thanks for the question. Yeah.
So, in the unfortunate case where the user loses his phone, his funds can be recovered as a 24-C, but that's only for on-chain funds, right? So is there any backup strategy for funds and channels at the moment?
That's also a great question. Thank you. So the question was, what happens, with the funds and the channels if the user loses his device? So there's currently channel state that's kind of stored on disk. And what we want to do, like next to the seed, we also, like that's something that can be backed up in like a binary blob, right? And this is some of like the services that could potentially be offered for users where you offer some kind of, like these are things where like you offer a way to back that up to some kind of cloud service, right? And obviously, yes, that creates a certain type of, I guess you could call it centralization. But I feel like the ecosystem is still so immature that we can still figure out solutions for that. So I by no means have a good answer at this point.
I was wondering, maybe you could derive from the 24-C some sort of cryptographic address or something that only the user himself can access that file.
Yeah.
So the data has to be kept somewhere, but it's not accessible for everybody else.
Yeah, yeah. Yeah, there's a lot of cool crypto stuff we could do to make that easier. But like I said, this is like an early alpha, so we don't have all the right answers yet. Thanks. Yes?
So the first comment about the previous question. Well, the easiest way to probe is just to dump it to Dropbox or OwnCloud or whatever else. So you just save in the database of channels, right? And then you don't have a problem. And the question is, do you plan to support hardware wallets? If yes, then when, roughly? And the second question is, are you open source and where I can find your code?
Okay, thank you. Those are 3 questions. So the first question, the first question was, do we support hardware wallets? Yeah. So currently not, but we want to. And this is all a question of prioritization, right? And this is where we want to release something to get that conversation with the user going, hear about what you guys want, If everybody screams at us, like, why don't we have hardware wallet support? We're obviously going to prioritize that. If everybody screams at us, hey, we want iOS now, and then we're obviously going to emphasize that. So it's all about like what the users want, what they need, and we're very open to those kinds of suggestions. And the second question?
Open source.
Yes. Oh, sorry. Yes. The GitHub repository was linked, and I'm going to tweet the slides afterwards. So it's under Lightning Labs / Lightning App. It's all GPL. Yeah. What? Sorry. What would happen if 1,000? If they copy it? Well, that would be great. It's open source. Sorry? Our business model? That's a good question. So I mean, this is early days, right? We're like an early stage startup. We're like 8 people, and 8 people full time. Some interns, some designer around that. But we're just starting out, and right now our main kind of goal is to build out the infrastructure. We're contributing obviously to the specification. We're building LND, and there's so many open questions right now to be answered before we get to that. And I think we still have a lot of learning to do. Build out the ecosystem, build out the platform, the apps, to even have the right answers for that. Right now, yes, build out the infrastructure and learn as we go. A lot of hard questions. Okay, I guess with that, thank you very much, and yeah.
Daniel? Hier, wo? Egal. Mehr hier. Ja, weiß ich nicht. Gut. Ja, super. Achso, das heißt, ich kann immer unter die Folie laufen mit meinem Gesicht. Nice.
So let's continue our meetup. Rene is a data science consultant and he's actually been deep diving into the Lightning Network just 2 months ago, right? Something like that. And this talk will be very deep and also very long. He told me it will be at least 1 hour. So I hope you all have enough Sitzfleisch, right? Okay. Rene.
Yeah, thank you. Is it okay for you? Thank you. Is it okay for you if I try to do it without microphone? I will speak up a little bit, and if it's not okay, you tell me and I take the microphone, but I don't want to hold it all the time. Take the microphone already? Okay. Good that you said this, I'm happy. Okay, so yes, I've been actually interacting with the Lightning Network protocol and paper a little bit longer than 2 months, but it's happened that I've never been public about this. I've all did this in my room at home, reading this stuff, and then I went to the Lightning Hack Day in Berlin, and I met some people, and it was a great event, and therefore today I'm here. So I hope this will be helpful for you. Also, I don't know the audience, so I hope the level of the talk is at the right level. I can speed up the first part. So the talk is structured in the following way. I've been told that when I do a talk, I should always start with something that everyone already knows so that we're all on the same page. Right? So the first quarter of the talk, I will solely talk about Bitcoin transactions, something that you probably all know, but we need those to understand Lightning, so I decided to put them in. If you're really bored, just tell me and I skip them. Afterwards, I will talk, hopefully half of the talk, about payment channels and routing. And then for the last quarter of the talk, I would talk about stuff that should be happening in Bolt 1.1, so the future specification of the Lightning Network Protocol. So for all of those who wanted to really see Lightning right away, please hold on a little bit. Lightning is coming soon, but it is coming. So I want to start with a standard Bitcoin transaction. As someone who is interested in protocol work, that's the stuff that I'm looking at because that's what's going over the network wire. And if you look at this, it has 6 data fields. So yeah, I should mention, this is basically a summary of what you can find in the Bitcoin Wiki, right? It's the Bitcoin Wiki article about transactions. So the first field is a version number. It has an in counter, which tells me how many inputs are in my transactions. It has a list of inputs. It has an out counter, a list of outputs, and a log time. And when you want to visualize this, this would probably look something like this. And you can even visualize this a little bit more. And what you realize actually is that, I don't know if there's a pointer in here. So, the mouse pointer is going here. So what you see actually is that the main part of this entire transaction, where the interesting data is just the scripts, right? So you have the scripts in the output transactions that basically define how the input script should be in order to be able to spend the transaction. And then here you have the input transactions scripts, and everything else is just a little bit of protocol overhead, right? It's just saying which transaction hash am I referencing, what is the index of the output, and what is the length of the script. So that's basically how such a transaction looks like for a computer scientist. And, wrong direction. And what Bitcoin really is it's a chain of Bitcoin transactions. So what we see here is we have a chain of transactions that has actually an output set of 3 unspent output transactions, at least if I counted correctly. So you can see here, I don't know, so you can see here there is transaction D that has this output here that is not being spent, but its input is referencing to this output over here. And then I see already, I miscounted myself, so I forgot that this is not an output, so it only has 2 outputs. Sorry for this typo here. It's funny, I had 2 outputs before, but then I changed it. So, and then there's this output that is not being referenced by any input. And so I don't know why the slides are not
progressing. So yeah, the outputs are referenced by the inputs, and there's a script in the output that defines how the transaction can be spent. And owning Bitcoins, by the end of the day, just means that you know how you can spend this Bitcoin. So you have to provide some input script that fits the output script. And when you're able to do this, you concatenate the input script to the output script. And then the script needs to evaluate to true. So the question is, how does this really look like? So in the, I would say, standard use case, or the use case that we've been knowing for most of the time, we're spending by a pay to pub key hash. What this means is that we have a script pub key, which is usually the script that is being in the output transaction, on the output script. And most people might have seen this. It looks pretty much like this. So we have two opcodes, duplicate, and calculating the hash. Then we have the public key hash, which is basically your Bitcoin address. And then you have to check if this is equal to something different. And then you have to check the signature. We will look into this a little bit more in detail. And then you have a script sig, which is the script in the input of the transaction. And in this particular case, it should only provide two data fields, which is a signature and your public key. And for explanations, the opcodes, which is basically the instruction set of the Bitcoin script, are written in capital letters. It's the script language within Bitcoin, and when I put those funny brackets, which kind of look like HTML text, what I mean is data. And then the complete script is concatenated, as I said before, so it looks like this, and hopefully the data matches perfectly so that you can spend the transaction. So I took the time to actually display this because it's being, as I said before, evaluated on the stack machine. So what this means is we see our pointer here that shows to the signature, and this is data. Data is being pushed on the stack, which you can see already here on the ground. And then the pointer, the script goes to the next element, which is the pub key, which is also pushed on the stack. And then it has this opcode, opdupe, which means take the top element of the stack machine, duplicate it, and push it on the stack too. So now I have the pub key twice on the stack, but I take it off right away because I have this opcode opthash 160, which takes the top element, it calculates its 160, I don't know how you would pronounce it, RIPE-MD hash, and then it pushes it back on the stack. So now it looks like this. Now comes the pub key hash that is being provided in the output script, and we have this op equal verify. So what this does is it takes the topmost two elements of the stack and it checks if they are the same. If not, the script terminates here, so you weren't able to provide a proper address that when hashed goes to the hash. If it's the same, you have to do another sanity check. The signature has to be the same that according to your public key. And if all of that works out, then congratulations, you have been able to spend your Bitcoin, do a new transaction, define a new output, and what you would probably do is you have to broadcast or publish. I will use these terms interchangeably, completely same meaning, but you have to broadcast or publish that transaction for the network to verify it. And with the network to verify this, I obviously mean the Bitcoin miners who will build the next block. So what they do is they collect all the published and valid transactions. Actually, they validate them themselves, obviously. Transaction can only be valid if the input, for example, has not been spent yet. This is how the double spending problem is solved, as you all know. In particular, the hashes of the transactions are being collected. Most likely, those transactions that offer higher mining fees, which are just inputs that have not been assigned to outputs. As I just said. And then the miner, they collect as many transactions as they are possible to fit into one block. As we know, the block size is currently 1 megabyte. And as we saw before, the transaction has quite some data. So there is a cap of how many transactions would fit in one block. And the first transaction in the block is a very special transaction, I think also called the Coinbase. It doesn't have a specific input. but it can spend something. And this is how new Bitcoins are being generated. And only the miner, obviously, who finds the block is allowed to put this transaction into the block, and it also, of course, has an impact on solving the hash collision. So yeah, for the block, there's also some additional metadata, for example, the hash of the previous block. This is obviously needed because otherwise we wouldn't have a blockchain. And the nonce, the extra nonce part of the Coinbase, as I said, the Coinbase changes for the hash collision, and then we compute the Merkle tree of all the hashes. We look out for the hash collision, respecting the mining difficulty, and if your transaction was in this block, congratulations, now your Bitcoin is really spent. So first of all, you have to provide an input script that validates the output script, and then of course the miner has to be able to verify it and mine it actually at some point in time. So we already had someone brave before when I said I don't want to use the microphone. So now it's your moment to be brave again. It's the time to ask questions about Bitcoin, because I think everything that we saw right now we need for the remainder of the talk. Great, so I could have skipped this entire part already. And thank you, at least. So finally, let's talk about Lightning. I just really love taking pictures of Lightning from a balcony, but that's probably not the reason why I'm here today. We want to talk about the Lightning Network. I think that's the only redundancy to the previous talk that I'm giving here. We have some well-known properties that the Lightning Network has or should have. First of all, it should be backed by the Bitcoin blockchain and nothing else, right? So no, the Lightning Network is not an ICO, right? I saw someone before raising their hand, and I get these questions asked several times. I wonder what's happening with the people, but it's not an ICO. However, I want to say it can be blocked also by backed by different blockchains. It's possible to merge blockchains with the Lightning Network, which I think is a pretty strong and cool feature of it. It should offer fast or, let's say, instant payments. And the cool thing is it's backed by the blockchains, but when you want to do a payment, the transactions that you're actually doing, they are possible without the need for you to wait for the blockchain to confirm them, because they're not directly being seen by the blockchain. Then the fees should be low, and this actually makes micropayments possible. There was just today an amazing Twitter discussion going on about whether the fees are too low and if this is really working. But yeah, if you want to ask me about this later, feel free to ask me. I'm just smiling when I think of this. It should be trustless, which is a core feature, right? So trustless means you don't have to trust anyone or anybody in order for this to work. Actually, you do, right? I said it's backed by the blockchain, so you have to trust the blockchain. But since the blockchain is completely decentralized, we decided it's a good idea to trust the blockchain. Hopefully more people in the future will decide it's a good idea to trust the blockchain instead of fractional reserve banking or whatsoever. But so it's not completely trustless, you have to trust the blockchain. But you don't need to trust any custodian or third party or whatsoever. Or you don't even need to trust your channel partner, which is even greater. You be your own bank, as we have heard before. So you own your funds at any given time. It's one of the craziest things. My mother, she's 70 years old, and she worked at a bank. And I knew if I'd asked her today, what do you think about Bitcoin, she'd be like, oh no, that's bad, you know, because she's old and the media and so on. But I described her the properties of the Lightning Network and said, can you imagine there is a way of doing a payment from here to Australia within 1 second, and before the second happens, you have the funds, and at the moment where the payment happens, the Australian person has the funds. And she's like, yeah, it's impossible, and if that was possible, it would transfer the entire banking system. I'm like, yeah, that was the answer I was looking for. It's called Bitcoin. Lightning Network. So that was my personal moment where I decided, okay, I really want to look at the Lightning Network, yeah.
You're saying what it isn't, and
sure.
Right? It's not an ICO and it can be extended, but you're not saying what it actually is.
Well, I said these are the properties, and the rest hopefully comes with the talk, right? So if I still haven't said it, no, perfect. If I haven't said it at the end, please ask again, right? But I hope, well, I can actually say it already. It's Bitcoin. No, it's Bitcoin. Actually, you will see it by the end of the talk. I'm pretty sure you would agree, but I mean, we can have a discussion. So it's decentralized, that's a property of Lightning, and something that always makes me really, really angry is if I see people on the web and they're like, yeah, I saw this picture of the Lightning network, and it's very centralized. Yeah, just having hub nodes and super nodes doesn't make a system being centralized, right? The decentralized property comes from something very different, from the trustless property, for example. Okay. So maybe this already gives you a little bit more of an answer. What the Lightning network is, it actually has two main components. The first component is the bidirectional payment channel, and we're going to talk a lot about this here today, what the payment channel is, how it works, how it operates, and why it actually works. I want to say first, there's three known methods to construct those channels. The first method by Poon and Draja, hope I pronounced the name correctly, are the ones that we are using today. They are the ones that were proposed in the Lightning Network white paper. They're basically the penalty revocation-based system. They work. They have a little bit of implementation overhead. So Christian Decker suggested L2, which requires a Bitcoin soft fork. So we cannot use this proposal right away, but it would make the life of Lightning developers, I would say, easier by, I don't know, probably a factor of 10 or something. And then Christian Decker, also with his PhD supervisor, Wattenhofer, wrote his main publication for his PhD thesis, I think, about a payment channel construction which is based on invalidation trees, which is also, I think, a pretty nice, neat working idea. But yeah, I mean, they're off the table for discussion, I would say. So the main component for a payment channel to work is the revocable sequence maturity contract. It's a crazy word, RSMC, which basically comes to us via this opcode, object sequence verify, which also people sometimes call object relative log time verify. I will explain later what it actually does and means. I just want to do a shout out to Bitcoin improvement proposal 1112. It's like in Germany, the fireworkers, right? And it was a really important Bitcoin improvement proposal, because without this, we would not have the chance to do something as crazy as the Lightning network currently. Maybe with the invalidation trees, I don't know. The second component is that we are able to route payments through the network of payment channels, right? So once I'm able to do a bidirectional payment channel, and actually I kind of forgot a word in here, it should be a trustless bidirectional payment channel, but I said this before. Then we do routing payments through a network of payment channels, and also the routing happens in a trustless manner. And the routing is basically achieved by hash time lock contracts. I already had the argument with some people. I would say they operate fairly similar to the RSMCs. So I will today talk a little bit more about the RSMCs and say, well, basically the hash time lock contracts are coming from that. Just you have to add another pre-image as a secret to trigger the payments. So yeah, what is the purpose of the trustless bidirectional payment channel? Basically, this is now just saying again what's the purpose of the Lightning network. So we want to send payments between two parties. I make this really fast, it should be instantly. Like updating a balance sheet for accounting, and it's only bound by the end of the day by network traffic over the internet. So as fast as my network traffic is maybe to you, the often we can update our payment channel. And there's no direct involvement of the blockchain, at least as long as everyone is playing by the rules, right? In the beginning, to open the channel, we heard this today, we have to involve the blockchain, but afterwards we kind of don't need it anymore. We don't need to trust any partner or other side, we just don't. Again, the blockchain can be involved if problems arise. And I think that's one of the unique and important features of a payment channel. If I use it bilaterally, there's basically no fees involved, right? I mean, I can just send payments back and forth all the time. No one will charge me fees. The payments obviously can go in either direction. And I don't know about you, but when I read something like this, I start to be curious. I'm like, how the hell is this technically possible? And it seems a little bit crazy that this would work. It's a lot of hard requirements, and it's actually one of the reasons why I think Lightning is such a cool thing, because it's just such an amazing solution to this problem. So also for this, I got a little bit bashed before the talk. I do a comparison with HTTP for the technically savvy people to get a motivation for this. It's not the best comparison, but I asked on Twitter and in groups if someone knows a better one, and no one provided me a better one. People came with, yeah, a payment channel is like an abacus or so. Yeah, it's true, but that's not even a motivation on a technical level. So I will stick with this HTTP example. Who of you knows HTTP on a protocol level? Okay, perfect. Because if no one would have raised their hands, I could have skipped the slides. But for those who know HTTP on a protocol level, we know it's a request-response protocol, which means you, as the client, I make you all to clients now, or your web browser, which is the client, you can make a request. And then the server can give you a response to the request. That's how it's designed, right? And according to the protocol, the server cannot initiate a communication with the client, right? It's not that you have your computer on and at some point in time there's just some web page popping up and loading because some web server out there decided that they want to start a conversation with you. You are allowed to start the conversation. That's how it's designed. That's how it's supposed to be. However, I can go on a website like Twitter. I'm on the website, and at some point in time, there pops up a notification saying me there's something new. Right? For us nowadays, it's very common. But if you think of HTTP, you're like, how? This should be impossible, right? This is not in the protocol design. And what the people are doing there is they are, I would say, abuse the protocol, right? And the abusement is called the server push or long polling. And I would say it took us 10 years of World Wide Web to figure out that we could do this. Maybe some smart people knew this before, but this feature took 10 years of World Wide Web to get around. So how does the HTTP server push actually work? Well, you load the web page, and after your web page is being completely loaded to your browser, the JavaScript Ajax machine is doing an HTTP request, and the server just looks if he has some information for the client, and if he does, he gives the client a response. And otherwise, he says, well, I might defer the answer to some point in time in the future. I just don't answer, right? And the TCP socket that HTTP is built on top is obviously staying open in this time. And then maybe if new information for the client is available at some point in time, or if the client opens a new web page and can't receive the response anymore, or the server might just do this for a heartbeat to see if the client is still there. The server can then say, well, I will now talk to you. From an end user perspective, from you will just see, oh, there's something new on my website, something has changed, right? And you will not see that the protocol has been abused. So usually you don't know there's an Ajax request pending. So if you want to learn more about this, you can look at the Wikipedia article or at any RFC, or I don't know where it's written down. Payment channels in the Lightning Network are being constructed basically, all forms that we know currently, in the same fashion. We defer some action that usually is part of the protocol to some unknown time in the future. And then see if we really do it, or if we do something else, or if we, well, do whatever, right? So Bitcoin obviously is not a request-response protocol. It's more like a broadcast gossip protocol. But still, we can ask ourselves, what could be deferred to the future? And what is actually being deferred is the transaction spending outputs that are held back from being broadcast, right? So I construct a transaction, I sign the transaction, I do all of that, but for some reason, I just decide not to publish this. And later, the transactions are purposely tried to be double-spended, right? So I kind of like forget this transaction, do another one, and say, well, that helps me to create my payment channel. And well, obviously, since double spending has been resolved by blockchain technology or by Bitcoin, better said, this cannot happen. So Lightning, or the Lightning Network protocol, is actually, one purpose is to make sure that the correct transaction is being spent later. But double spending is easy, or creating several transactions that spend some output. But making sure that the right one is being spent, or if the wrong one is being spent, that something bad happens, that's basically the entire construction for payment channels. So we'll look at this in the next couple of slides. So payment channels to Bitcoin are basically what the HTTP server push is to HTTP, right? That's kind of the analogy. So it's just non-obvious use of the Bitcoin protocol, and I would say it also took us a little bit time to figure out that this is possible, although I would say not 10 years. It was quite faster. Well, we are further. So how would we define what a payment channel basically is? So a payment channel is a 2-of-2 multi-sig Bitcoin address, together with some people sometimes call it smart. I don't know what makes a contract really smart. I think it should be Turing complete, and I haven't calculated this through if it's really going to be Turing complete by this construction, but let's say it's some at least intelligent way to form a contract. So a 2-to multi-sig address means that the output script of the transaction requires 2 keys to be able to spend the transaction. Right? So you have some output, and the script looks like this, that you need 2 keys. And it's a form of a pay-to-script hash. I haven't showed this before, but I will use this now. At least give the example. So the script pub key looks a little bit different than before. It basically just says, well, calculate some hash. Here is the hash of a script, which is later the input script, which is used to spend, and see if they're equal. Right? So the output transaction always has the same size. That's one of the advantages, I would say, at least a slight advantage, is that the output is always also small. And then you have the input sig, the script sig, which is the input, and it's basically just a couple of signatures, and then the serialized script, right? So you have the script, and you serialize this to a string, and you put this there. Already think about it later on when being evaluated, it's going to be put together, right? So on the stack, it looks like this. There are the signatures, and then there is the serialized script, and then op hash is calculated, and if op hash calculates to the same as the script hash that is being provided, well, congratulations, you can spend the transaction. So if you, as the person who wants to spend the transaction, know how to formulate your input script, congratulations, it's going to work. And in the case of the NM multisig, we will see the output is exactly the same as above, and the input script basically looks like this. You have op-m, you have public keys, and then you have op-n, check multisig, which is one opcode, and that's your script. So how would this look like? We have some output in the very top from some transaction that is being unspent. And let's say Alice can spend this with a pub key hash with her key, and she's creating a so-called funding transaction. I will use this word quite frequently during this talk. And the funding transaction, so by the way, a reminder for those, or disclaimer better said, for those who are already experts on the Lightning Network, first of all, why are you here? Second of all, the first couple slides are slightly wrong. I will correct this later on, but for educational purpose, I purposely omitted something or made something wrong, but you will see what it is later on. So Alice decides to create this funding transaction. The funding transaction has this 100 millibitcoin as an input, and it has one output that can be spent, and the output is 100 millibitcoins, and they can be spent by Alice and Bob's key, right? So here in the bottom, I provided the script pub key, which is basically just the multi-signature script. And also for all the future slides that look similar to this, the legend is, if a rectangle is white, it means it's already broadcast and mined the transaction. If it's gray like this, it means it has not been broadcast yet. And later on, we also see something like red, which has 2 meanings. Either it cannot be mined anymore because it would create a double spend, or it should not be broadcast because you would lose your funds if you do so. And green means, well, right now you definitely should broadcast this, right? This is where watchtowers, for example, come into place because otherwise you might lose your funds. So then when we have this funding transaction, what is being done is we create a spend of this transaction. We call this a commitment transaction, or later on I will just say CTX as a commitment transaction. And the commitment transaction is providing a script, a script here, which basically is the multi-signature script. And the input, because the script evaluates true, can decide how the next outputs are going to be. And as I said, I'm doing a slight mistake here. But again, for educational purpose, we have 2 outputs. One output, let's say, is 70 millibitcoins, which Alice can spend, and 30 bitcoins that Bob can spend. Right? So Alice has created a payment channel, and she had 70 millibitcoins on her side and 30 millibitcoins on Bob's side. And actually, this is how the situation looks like. And now the subtle thing is, once the commitment transaction is being created, and it's being signed by both sides, because we are on a multi-signature wallet again, then we can publish finally the funding transaction. But we shouldn't do this before, because if Alice publishes the funding transaction before she has the commitment transaction signed, what Bob could do is he could say, well, I never sign any transaction from you unless you give all the funds to me. Or, well, you can maybe keep one Satoshi, but I mean, that's better than having non-Satoshis, right? So please, right? So Alice doesn't want to trust Bob, so she says, well, Bob, I only initiate this payment channel with you if you sign this transaction first, right? And you can sign a chain of transactions. The transactions don't have to be mined, they don't have to be broadcast, you can just do this. So as Bob has signed the transaction, Alice is publishing the funding transaction. Great. And the commitment transaction encodes the balance sheet of the channel, right? This basically tells me 70 Bitcoins with Alice, 30 Bitcoins with Bob. And it's called commitment, I would at least say, because both parties already did some commitment, right? They already signed this and they commit to this contract because basically there's a contract being built, right? I don't know if it's smart yet, most certainly not this one, but I mean, there is some form of contract. And then what they can also do is, because, and again, this is not completely right yet, both parties have a copy of this transaction, they can broadcast it at any time, right? They don't have to trust the other side to broadcast it in order to get hold of the funds. So what we can do next is we can create a potential double spending of our funding transaction, and we can create a second commitment transaction. And the second commitment transaction gives 80 millibitcoins to Alice and 20 millibitcoins to Bob, which effectively means that Bob just sent 10 millibitcoins to Alice, right? I mean, of course, Alice and Bob both have to agree on the second commitment transaction. For Alice, it's probably easy to agree because she gets more Bitcoin, and Bob probably does this because he wants to send Bitcoins to Alice, right? So that's why I already noted that Bob effectively received the Bitcoins, not like Alice stole the Bitcoins, right? Because then Bob would probably not sign this. Question is, anybody seeing a problem with this? Yeah, I know you see a problem. I want to see someone else see a problem. Don't want to wait too long. Yeah. Sorry. Yeah.
Everybody could broadcast the old.
Yes, exactly. What prevents Bob, who just sent Bitcoins to Alice in order to get pizza today at the Lightning, well, it's actually Bitcoin meetup, sorry, but at today's meetup, what would prevent Bob from broadcasting and having the miners mine transaction 1? Because then Bob just effectively stole 10 millibitcoins from Alice. Right? And this is a problem. The question is, how can we prevent Bob from doing this? Yeah, centralization would be a great idea. Probably it would work, yeah, if there's a custodian who holds these transactions, right? Even with centralization, it might be a little bit difficult, at least if it's still on the blockchain, because when Bob is signing the transaction, it's not clear that he gives the transaction back to the custodian, right? It's a digital good, so even if Alice has access to the PC of Bob, he could have made a copy or whatsoever, you know, piracy, right? You can just steal the transaction. So our goal is to somehow make the old commitment transaction somehow unpublishable. If we were able to achieve this, then we would have a payment channel. Okay. Yeah, exactly. Yeah. So what we do in order to achieve this is we modify the output of the commitment transactions, and we modify the output in this way with an RSMC, that a fraudulent publishing will be punished by will punish the publisher. Of course, it will not be punished by the publisher, it will punish the publisher. For example, by giving the silent party, the party that didn't publish the transaction, all the funds in the channel. Right? This would be a huge punishment. Right? Because now if Bob would broadcast this, Alice would get 100 millibitcoins, not only the 30 that she should own, or the 80 or whatsoever. Okay, so graphic changed quite a lot. Now our commitment transaction is on the left side. Right? It's not the funding transaction anymore, and the commitment transaction is unpublished at this point in time, right? We don't have a second commitment transaction. We haven't updated the channel yet. What we do again is we create some kind of a potential double spending of this commitment transaction. So we have a revocable delivery transaction and a breach remedy transaction. Technically, I think it's two paths of the same transaction. I mean, also if you look at the script at the bottom, you see that the script of the write transaction is the script where you have an if path that can spend the transaction with Bob's key, or you have an else path where the transaction can be spent with Alice and Bob's key, which is the revocation keys of them. So maybe I take a little bit more time explaining what's happening here. What we do is we keep the output 0 that gives 70 millibitcoin to Alice. And Alice can always spend this. But the output 1, Bob cannot spend directly. There's two possibilities. Either we go in this revocable delivery path where Bob can spend the output. But Bob can only do so, in this case, with a relative time lock of 144 blocks, so 1 day, after the commitment transaction is being mined. Right, so if this commitment transaction by some degree is being published, Alice can directly spend the 70 millibitcoin output, but Bob has to wait 1 day until he can claim his output. On the other side, if Bob and Alice work together, they can together claim the output in the breach remedy transaction. And actually what they need is this revocation key number 1, and this working together takes place when the second commitment transaction, so an update of the channel is being created. Yes?
How are the 144 days coming to pass?
144 blocks. What do you mean how they're coming?
Are they just decided upon by the protocol level, or why is it just 144 days?
So yeah, I think in the protocol level there is no specification of how large the number must be or should be. The thing is, so I don't want to know if I want to give the answer right now, right? So the problem is you have to give Alice some time if Bob published this transaction in order to go to this breach remedy transaction. That's why you have to have a certain time. If it's too long, it's not usable again because the funds cannot be claimed, right? So you have to have some certain time frame, and you can configure this currently in your Lightning implementations. So if you have C Lightning, currently it's a customizable option, yes. Configurable trade-off. I just say it because it's on the mic then too.
If you make it longer, you have more time, but your money might be locked longer. And if you make it shorter, your money is not locked longer, but you have less time to react. It's a trade-off.
I think it becomes clearer in the next 2 or 3 slides. No, it's fine. Yeah. So there's this potential double spending, right? And what's happening now is, what I just said before, within 144 blocks, Bob cannot spend his output. Only Bob and Alice can together spend this output. So let's assume the commitment transaction is really the current channel balance. Then Alice would not know the revocation key of Bob. And then after 144 blocks, Bob would be able to claim his funds. Right? But if for some reason they decide to create a new commitment transaction, what is being done is we have a second commitment transaction, exactly the same numbers than before. Bob sent 10 millibitcoin to Alice. And now, again, we have the revocable delivery transaction and the breach remedy transaction, right? So what happens with this? The thing is that the new commitment transaction will only be signed when, in this case, Bob discloses his revocation key to Alice. That's part of the protocol. Alice must not sign the second commitment transaction here if she does not get the key from Bob. Right? That's the important information. And that's also the information that she needs to store all the time and that the watchtowers later use or something like this, right? But once this is being done, what we have is, we have this setting where the commitment transaction 1 could be published. The second commitment transaction cannot be published anymore, right? Because it would yield a double spend, but the first one is already published, then also the spends of the second commitment transaction cannot be published anymore. But Alice can now yield the breach remedy transaction because she has Bob's revocation key. Okay, is that clear? Fully? It's, by the way, always a good moment to ask questions, not only if this.
Is that automatically done?
So that is the protocol, right? So that is being specified by the protocol, right? Which means a protocol is a form of a contract, right? It's a way of how two people or nodes communicate with each other, right? And the communication is that in this particular setting, Bob says, well, Alice, I want to send you 10 millibitcoins. Would you please sign the new commitment transaction? And Alice says, yeah, I would like to do this. The problem, however, is if I just do this, you can spend the first commitment transaction. That's not so great. So please, in order to have me protect me from you, give me your revocation key from the first breach remedy transaction. And once I have this, right, I cannot do anything with this if you just don't publish the first commitment transaction. So if you do this, you don't have any risk. But if you do, I will sign the second commitment transaction because now there's no harm if you publish the first commitment transaction, which is an old channel stage, right? So I made a huge punishment, created this, right, in order to do this. So I've been, yeah?
So to get it right, and the person who wants to send coins gets the revocation key. Because he's doing the risky thing, right? The person who wants to send away some of his coins. So when he loses balance in the channel.
Yeah, no. So the person who sends the coins discloses his revocation key from the last commitment transaction, right? That it can't publish the transaction with a higher channel balance on his side. Actually, but I omitted something, and I think it's on the next slide. It's always difficult for education to not put everything in first, right? So you always have to make some mistakes on purpose in the beginning. So some remarks on the presentation that I made here on the simplifications. In order to ascribe blame, right, you don't only have commitment transaction 1, 2, 3, 4, right? You have 1B for Bob, 2B for Bob, 3B for Bob, but you also have the same for Alice, right? So actually when the funding transaction, the first one is being spent, Bob gets his commitment transaction and Alice gets her commitment transaction. So if the channel balance now is being updated, Bob also receives the revocation key from Alice from her commitment transaction, right? Where Alice receives the revocation key from Bob's commitment transaction. So in order that no party can actually publish an old state, because the state might change all the time, right? It might be higher, lower, and so on, right? So everything that we saw, all these transactions, they're actually existing twice. So if you look, if you look at the Lightning paper, it's quite, I would say, frightening, right? So you open the paper and it sounds nice, it has a nice intro, and then at some point in time you see this huge graphic that's basically one page, right? And it's just these transactions and this entire tree of how those transactions exist and what happens in any case, right? So yeah, but that's how it is. So for the slides, I kind of like shrinked it down a little bit. Hopefully not confusing you, but adding value. Yeah, you had a question.
When does the punishment come in? With the wrong commitment?
Yeah. So the thing is, if you look at it, right? As I said before, maybe I go back. As I said before, Bitcoin is a chain of transactions, right? We don't talk about blockchain right now, right? It doesn't matter that the transactions are in blocks and the blocks are chained, right? It's really a chain of transactions. The first Bitcoin creates out of, well, it's not thin air, there's proof of work in it, but I mean, it's just there from the Coinbase, and then it's being spent at some point in time, and then it's spent again, and it might be like evolve, right? So here, this is also a chain of transactions, right? So you have the, so you have here the funding transaction, which is being referenced by the commitment transaction, right? So this is a double spend of the funding transaction. So now only this or this can be published in the blockchain, right? Both is impossible, right? By Bitcoin protocol definition. So if this one is published, now we go into this transaction, and what this transaction does is it says, well, if Alice has the revocation key of Bob, and she has her own anyway, well, I mean, she can spend this output. And if she doesn't spend this output within 144 days, not days, block times, right? Then Bob can reclaim his output. Right? So assume the second commitment transaction never existed. Then, of course, Bob would not have revealed his revocation key. Alice cannot do this. And then, of course, only Bob, after 1 day, can spend the output. So this is where the punishment takes place. Yep.
So basically you have a second balance apart from your wallet in the
Yeah. So the thing is, I haven't talked about the Lightning Network yet, right? Important distinction, right? It's getting even more, at least full, complex, right? If I put in the HTLCs and the network part and all of that, right? I've just talked about a bidirectional payment channel between you and me, right? And we can update this channel all the time, right? We had kind of commitment transaction 1, 2, commitment transaction 2, as you see, has, again, revocation keys. It's different ones, right? It's revocation key 2. They're derived from a hierarchical deterministic wallet, right? But we can update the balance in the channel all the time by just communicating to each other saying, well, I want to do new commitment transactions. You say, yeah, please give me your key. I say, yeah, you have to give me the other key in order for me to sign your commitment transaction, and so on and so forth. But what you can do at any time, you can publish the last commitment transaction that you have. And the last commitment transaction is the balance of your payment channel. Right? Because the spend of the commitment transaction, I mean, if you look at it, here in the first commitment transaction, it says 70 bitcoins for Alice, 30 bitcoins potentially for Bob, unless he is fraudulent. And the second commitment transaction says 80 bitcoins for Alice and 20 bitcoins for Bob, unless, of course, with another commitment transaction existing, he's fraudulent and shouldn't spend this. Yeah.
So the big difference is like in Bitcoin normal blockchain transactions, you commit like deltas, what you transfer, and in the Lightning, you have to transfer like the whole balance between those. It's not
Yeah. So you have a funding transaction that is the capacity of the channel, right? And you always, yeah, it makes sense. I mean, always spend the entire funding.
Okay.
Right?
Okay. You have to update it completely.
Yeah.
You don't commit the
Yeah. But as I said, the thing is, usually you never publish this. Right? You just sign those transactions, yeah, but you don't broadcast them because you want to keep the channel open. You want to be able to send money to me, and I want to be able to give it back to you. Okay. So yeah, probably I've already said everything that's on this slide now. So yeah, transactions are being created for every channel update. So the revocation delivery transaction and the breach remedy transactions are adapted accordingly. As I said, Alice also has her transaction tree. And then for every update of the commitment transactions, revocation keys have to be newly created. If you would use the first revocation key, then in the second transaction, if it's being published, you could already use it, right? So you have to have a new one all the time. Yeah, I already said they're coming from a hierarchical deterministic wallet. And the commitment transactions later on will actually have more outputs, not only one back to Alice and the RSMC, but there will also be the HTLC outputs. And we will look a little bit at how they work, but they enable actually routing through the network later on. Yeah, and so I have a reading for everyone here, if you're suggested in this, besides the Lightning Network white paper, which is the L2 proposal. It's a simple layer 2 protocol proposal for Bitcoin. It's written by Christian Decker and Rusty Russell from Blockstream, and I practiced to pronounce the name, Olaoluwa Osuntokun, hopefully I did it right, from Lightning Labs. And if you don't want to read the entire 20-page paper, I have a 10 to 15-minute summary on my blog where it basically gives, hopefully, a pretty good overview. Christian Decker read it and he said he was okay with it. So I was like, yeah, it's not too bad. Like, I found 2 mistakes. I'm like, yeah, which ones? I'll tell you. So yeah, there you can get a quick summary of it. So what have we achieved now with this construction? Well, we have a bidirectional payment channel. And it's opened with one on-chain transaction because the funding transaction has to be on the Bitcoin blockchain. And the channel can stay open for arbitrary time. We don't have to ask anyone to allow this to happen. And the newest commitment transaction, as I said before in the discussion right now, encodes the balance of the channel. Right? So old commitment transactions are being invalidated by sharing secrets, right, in order to prevent the other side for broadcasting them. And the balance sheet can instantly being updated, right, only bound by network traffic. And it effectively is allowing each party to send funds to the other party. Also, and that's a problem, only as much funds as there are in the payment channel, right? If I have 100 Bitcoins in my wallet and I only have a payment channel with half a Bitcoin, I only can send half a Bitcoin. Otherwise, I would have to, well, either do splicing, which is not being implemented yet, or even specified, or I have to create a new payment channel, or maybe I have other channels where I can route it to. You know, I don't know, but yeah. But in order to send funds, second, both parties have to collaborate in order to update the channel balance. Yes?
How is this making invalidation and a new commitment atomic, let's say? So if I would give this invalidation key before I get the new commitment, then I have a problem, and the other way around.
Yeah. So if you get the key before, it matters, because if you then decide never to update the channel again, right? If you then, so let's assume we have a channel, right? And I give you my revocation key, my current revocation key, without having a new transaction being signed. What could happen is that you would then say, well, you know what? I will never ever sign a new channel update again. Let's publish the one that we have. So I publish the one, and then you say, well, I claim all the outputs, right? So yeah, you have to keep track on your keys, right? That's again the protocol part. That's the maybe smart part, right? You have to have a smart way of communication. Don't do any mistakes. The good thing is computers are doing this. Once they're being programmed correctly, it's obviously, hopefully, always going in the right steps, right? So the difficult part is of, while specifying this, making no mistakes, thinking of each and possible way, but so that's the sad thing about this talk. I'm only presenting other people's ideas, but it's brilliant ideas. So.
You just said you wanted not to give me the key until the second commitment is signed.
Oh, yeah.
On the other hand, I do not want to sign the second before I have your key, right?
Yeah, right. Yeah, problem solved already for like 1 million years is too long, but so it's basically, I would assume, done with some kind of Diffie-Hellman key exchange, right, where I can like do this partially exchange of information and say I already go that far and this far, encrypted back and forth, right? So this is the gossip protocol overhead of how do you exchange this information, which I personally have black boxed so far, to be really honest. But at least from a conceptual level, I know with every HTTPS request on the web, something like this is working. So, you know, I mean, you have to black box at some point in time, right? So observed very correctly, right? But I think it's a solved problem, right? And I mean, we have to look at the implementation. Yeah, Flo.
So in between there are states where one party can publish two versions, but you can do actually both. So basically you provide a signature, you receive the revocation key, you receive the signature of the other transaction,
So then you have
and then you provide
half-time.
the other revocation key. And in between the receiver could publish both transactions, but you just do not consider the payment happened yet. So basically, whatever was the payment condition, you do not provide it yet until until the full state is invalidated and the new state is agreed upon. But in between, it's kind of fuzzy, but still secure.
So I wanted at some point in this talk to thank Blockchain Consulting for bringing all the people together and sponsoring this event. And maybe this is a good moment because Flo is working for Blockstream Consulting, doing Lightning there all the time. So therefore, he really knows his stuff. So thanks for jumping in here. Yeah, give it a round. Ah, yeah, sorry. Yeah. Yeah, exactly. Yeah, so the thing is the following. I mean, you can always do stuff collaboratively. It's something, it's really funny. So when I created this L2 write-up, I had some emails changed back and forth with Christian, also of me giving him criticism where his paper is not so clear to understand. And one thing I mentioned is that I was saying is like, yeah, I didn't realize that in the collaborative case, you always can do it with 2 transactions. And he's like, yeah, collaborative, we can always do anything, right? So if we decide to close the channel, of course, at the moment of closing the channel, we can forget all of our old state, basically, and just make a new spend and adapt it to the current fees, right? The problem, however, is that you do those commitment transactions in order to be able to force at any later point in time to be able to close the channel without asking the other person, right? The other person, in the worst case, could just have died away, right? I mean, it could happen, right? Or the computer burned away, right? The key is gone, cannot sign anything anymore. So hopefully your fees that you put in the commitment transaction were high enough.
That's the main benefit of L2.
It's true. In L2 you can later do this, right? But yeah, I mean, it's a problem. I'm not sure if this is the main benefit, but it's a huge benefit. It's a huge benefit, definitely. Okay, so the blockchain doesn't need to get involved, and there's no fees for updating this, right? I mean, of course, my channel partner could say, yeah, when we update this, I also want to have some fee, but I mean, you probably wouldn't do this. So the question is, where's the Lightning network of payment channels? Because we haven't seen this yet. And let's assume we have a trusting Lightning network. I already said it's going to be trustless, but let's assume for now we have a trusting Lightning network of payment channels. Before I start doing this, I want to explain this graphic because you might not have seen this. Basically what we have is we have Alice here, and Alice and Bob, they together have a payment channel. And here is the multi-signature wallet, which is the one that was the funding transaction. The current commitment transaction says, well, 0.35 Bitcoins to Alice and 0.15 to Bob. And then, of course, on the other side, Bob and Charlie have a payment channel where the balance is somehow distributed. So now Alice has the idea and says, well, I want to send 0.1 Bitcoin to Charlie. And she knows she has a payment channel with Bob, and she knows Bob has a payment channel with Charlie. So she goes to Bob and says, hey, I sent you 0.1 Bitcoin. Would you please forward this with Charlie? So she creates a new channel state. We already saw that this would work, right? It's trustless. It's great. Bob now has more Bitcoin. And then there's Bob. And Bob is a nice guy. He thinks he's honest. Right? And he says, well, I will just forward the payment. And then Charlie has the payment. Great. Only problem is Alice needed to trust Bob. We want to have it trustless. So both payment channels need to negotiate new commitment transactions while doing this with the breach remedy transactions and the revocable delivery transactions, revocation keys, all that stuff that we saw. The question is, could we change the output of the commitment transaction to some degree that routing works trustless? And the great answer is yes, it works, right? It's this great, amazing combination of great ideas out there. And the idea is the hash time lock contract, or HTLC. And what we do is we add another conditional output to the commitment transaction, and it can only spent by the recipient if the recipient within a certain time frame, and if the recipient provides the pre-image of some hash, right? So the pre-image means some data that when being put to a hash algorithm, it creates exactly this hash, right? Which, as we know, hash functions are not inverse, so you cannot brute force this, you really have to know this. And after the time frame, the sender can just reclaim the output, right? And I mean, as we saw before, there is some input script that we can do with this revocable sequence maturity contract, and the hash time lock contract basically works pretty similar. We also have a time lock. And yeah, so for brevity, I refer to the Lightning Network paper to look up how the transactions are all being created, because they also need breach remedy transactions and all of that. So you can look this up there. You can trust me, it works, right? And it's very similar to our previous construction. We can look at this from a high level, however. So again, Alice thinks now in the trustless setting that she wants to send some money to Charlie. So she thinks of some secret R. I don't know why R is always being used. S would be much more sensible for a secret, but it's R. And she creates the hash of this secret. And then she creates, so we see she had in her output, which she could spend in the payment channel, 0.35 Bitcoin. Now she only has 0.25 Bitcoin, and 0.1 Bitcoin is going somewhere, right? It's neither going to Alice, it's nor going to Bob, right? It depends on the contract and on the setting later when it's being spent. But she basically says, well, if Bob doesn't provide R, I can reclaim the 0.10 Bitcoin. I don't have a risk to do this. Right? And then Bob says, well, I want to have the 0.1 Bitcoin because I want to contribute to the network. A network is great if everyone participates. And he says, well, I can't claim the Bitcoin if I don't get this R. So how do I get the secret? Well, what Bob can do is he can say, well, you know what? I also just spent 0.1 Bitcoin. and I spent it to Charlie. She can only redeem it under the condition if within a shorter time frame she provides me with R. And if she does, great, I can send back R to Alice, and if Alice doesn't update the channel state, well, I will put it to the blockchain, because in the blockchain the contract is written down, and I get my money. So yeah, it's safe, great. So yeah, what Alice then does is she creates a different channel of communication, encrypted hopefully, with Charlie, sends over the R. Charlie now says, well, I have the R, I can claim this 0.1 Bitcoin from Bob. Now Bob's balance is already down again, but Bob says, well, now I know R, I can claim the other output from the HTLC from Alice. And Alice thinks, yeah, Bob must probably have paid Charlie, because otherwise he could not have known R. I mean, he could have guessed it, but as I said, hash collision is difficult for some reason. So yeah, now we can go to the moon, finally. So it's all there. Yeah, kudos to my, how do you call it, sister-in-law? No, I don't know. Anyway, she draw these pictures. I love it. This one is unpublished. The other one I shared on the internet before, but this one I always wanted to share when something special happened, and I thought today's talk would be great. So yeah, we can go to the moon. What does going to the moon actually... No, so if you looked at the first picture where we said hodl on lightning is coming, now it's the backside, right? Because the... Yeah, you know... Also, if you look at the first picture, it's really stupid because the roller coaster comes in some way and it looks like a Bitcoin Cash logo. And I'm like, oh yeah, did we really do this? But I realized it so much later, so yeah, it's not. What did the Bitcoin Cash people do? Actually, it's ridiculous. Okay, so what does to the moon mean, actually? To the moon means we created a trustless bidirectional payment channel. Yes. We used HTLCs to create a network of payment channels. And all this stuff is specified in the Lightning RFC. Right? It's a very technical document, also called Bold 1, Bold as Basics of Lightning Technologies. You can find it on GitHub. There you can also write down issues that you have, or in the wiki page maybe start, well, documenting is not such a good idea because it's documented already, but you can add to this or even fork it. There's 3 independent implementations of this, at least ones that are actively being maintained. I think there's also a Rust implementation, and I don't know if Python already is there. But there's C Lightning by Blockstream, LND by Lightning Labs, and Eclair by, I always say the French people because I don't know how to pronounce this. And it's, Async. Okay, so by Async. And it's already running on mainnet. However, bad news, we're not done. It's, we're not at the moon, we're to the moon, right? We're going to go at the moon, on the moon. So yeah, we have some problems with the Lightning Network, or Bold 1.0. So first of all, we discussed this already in the previous talk, what happens if a node goes offline, right? Alice only has a certain time frame where she can punish Bob for spending this. And the answer is, which I will sketch in a few slides. So this is just an overview, and I will talk about each and every point a little bit, is watchtowers. Then the topology of the network is partially unknown, right? I mean, the channels are being announced, right? So we know which nodes have channels with each other, but the problem is we don't know the balance, right? Because people decided for privacy reasons it would be great if the channel balances are kept private, because then we don't know how payments are basically being routed along the network. So the topology is partially unknown, which makes it really difficult to find routes and create a routing protocol or something like this. There's the Autopilot feature in order to resolve this. You can put a lot of network flow theory in there. Yeah, well, research has to be done. So in my former group in the university, there's this one guy who is really, really, I would say, one of the world's leading network researchers. And I sent him a mail. I'm like, do you know how you would do network flow calculating, routing in such a setting? He's like, no, I don't. And I'm like, okay. So it's kind of an open research question too. But you know, I mean, stuff doesn't have to be solved by the university. Maybe he really doesn't know it has been resolved, but you know. So then, of course, when the Lightning Network is being in use, channels could dry out, or we can have routes where the capacity is just not huge enough. So there's a concept called atomic multipath routing. I think a prototype is being implemented in LND already, but not published. Splicing would be an answer to this, in my opinion. So as a quick side note, when I decided to become more active in Lightning development, what I'm trying to do is to write the splicing specifications for Bolt 1.1. So this is the problem where I'm thinking about a lot, and I think it's hopefully rather easy, and I think it's already being solved, at least theoretically. I will say later what splicing exactly means. Funds are being locked up in payment channels, right? Right now, so my funds are in a payment channel. If the mining fees are high right now, I cannot withdraw them. I cannot use the funds otherwise, and if I don't find routes with this payment channel to other nodes, my funds are basically, well, not gone, but locked, right? Which is also bad, so splicing would also help there. Well, to some degree, because the fees would still be a problem. And funds are somewhat on a hot wallet, right? For obvious reasons, right? Because I mean, I need to maintain the state all the time. If I would put all those keys on a cold storage, I could not instantly update them, right? It would kind of like, create a conflict with the purpose of the Lightning network. So yeah, I have some idea how you could increase this, but probably it's not worthwhile talking about this yet, so I will skip this. And now I want to give some high-level outlook of Bolt 1.1, or of how I think Bolt 1.1 could look like, or what features would be in there. So first of all, watchtowers. So that's the problem, right? After 144 blocks, Bob can redeem his 10 milli Bitcoin. But what is if Alice was just not paying attention because Alice was offline, or Alice, I don't know, she was on vacation, her computer was down. It's you know, weird stuff can happen with technology. So, well, what you could do is you could have a third party, so-called watchtower, who keeps track. So the watchtower will be incentivized by getting a small fee as an additional output in the breach remedy transaction. And the revocation key is kind of shared with the watchtower. So then if the watchtower sees this commitment transaction was being spent, the watchtower will spend the breach remedy transaction. And he really wants to do this because he's incentivized by this small fee. And of course, you could also add more watchtowers to this. And Alice can have her watchtowers, and Bob can have other watchtowers. And the watchtowers, well, I mean, it's just a Bitcoin address which can claim this, or some script, right? So it's not even known by the other party. A great thing. Obviously, with all these transactions and keeping state all the time, it's probably, I think I heard 8,000 lines of code or something to put them into LND, which I thought was kind of crazy, but I mean, okay, so yeah, watchtowers. Then, as I said before, finding paths and creating connectivity in the Autopilot is a problem, right? So, I mean, for example, if you look at this node here, this one, yeah, somewhat here, exactly. If this disappears, all the other nodes over here would go away from the network and don't have connectivity anymore. So the network has an interest to open more channels and create a better connectivity for the network. So I would say a Lightning network is, by the end of the day, I mean, a bidirectional payment channel is already useful, but it's really useful if the network works, right? So if routing requests can successfully be routed. So again, we have a direct graph. The capacity of the graph is undirected. However, we're interested in the balance. The topology is only partially known. The weights are unknown globally due to privacy concerns. And even worse, the weights will dynamically change all the time, right? Because routing is taking place, and then of course the balance changes, right? So the graph changes its topology, and we don't even see this, right? So we can't even make a smart assumption and test this over time because the graph also changes, so it's weird. We have connectivity concerns which can be tackled by the Autopilot, right? So currently the Autopilot just connects with a high likelihood to already well-connected nodes, which might be a good strategy, might not be. We have to figure out, because I think we should avoid supernodes to some degree. I mean, obviously, I don't know if you realize there's this shitcoin dude who currently funded many channels. Right now, it makes really sense to connect to him, right? Because he has so many outbound channels. So if you want to make a payment, probably over his node, it will arrive somewhere. But I mean, if he goes offline, then it's bad, obviously. And yeah, we kind of want to avoid central nodes. which central nodes doesn't mean they have to be a super hub, right? But central in the sense of if this node is gone, right? It could be one node, so the network could have two sides. It could be just one node in the middle that connects the two networks, right? If this node disappears, it would be bad, right? So there we have to create a node that, yeah. So there's an ongoing discussion about the topology and autopilot stuff, which was also on the Lightning Hack Day, and I just wrote a summary protocol of the discussion there on my blog. Feel free to join the discussion. Basically, max flow defines how much money one node can pay to the others, and it could be computed if the entire information was public. The problem is this is not helpful if we don't have atomic multipath routing, which I explain in the next slides. And other solutions to this entire network topology problem could be splicing, or something that I recently came accidentally up with, really accidentally, are virtual payment channels. Yeah, so let's look at this picture. It's basically the picture from before. Charlie can't send her 0.3 bitcoins to Alice, right? Because, as we see, this channel here is a bottleneck. Bob only can forward 0.15 bitcoins to Alice. But the situation would be a little different if David was also on the network, and Bob had another payment channel with David, and David another payment channel with Alice, because now what Charlie could do is Charlie could route her payment to Bob, and Bob could send half of the payment over the bottom wallet and the other part of the payment over the top wallet. I mean, technically right now, Charlie could already do this by sending micropayments all the time, but she wants to just do one full transaction because she wants to pay a full bill and not 90% of the bill and later find out the channels have changed, right? So you have to resolve this in a smarter way where you can be sure if a flow exists, it actually really goes out and works all together. I think technically a solvable problem, but not being specified or implemented yet. Splicing, how do you update the capacity of the channel, right? It's an issue actually being asked on the Lightning RFC. Why can't I update the channel capacity? It should be easy, just make a new funding transaction, basically close the channel, open a new channel. Problem with the simple approach is it's not very flexible, it's not very dynamic. You have to wait for block confirmations, maybe you can do it with less confirmations. So our goal is to do only one blockchain transformation and be non-blocking. Non-blocking meaning that while you do the splicing operation, changing the channel balance, you should still be able to use the current channel all the time. So splicing would give a lot of flexibility, in my opinion. It's really personated right now. It's really opinionated. Because what would happen is I can send all my funds via Bitcoin in one transaction, or I can just, at the same time, do a huge payment channel and just put all my funds in this payment channel. And then when I want to pay later, Lightning maybe doesn't find a route. So yeah, I can, in the best case, splice out a transaction and fund a new channel. And Bitcoin wallets, that goes a little bit in the direction of the previous talk, Bitcoin wallets will secretly use the Lightning network for transactions. We don't even see the channels. The user doesn't have to know this. And if atomic multipath routing kicks in, great. If not, splicing comes and rescues us. So yeah, the speed of transactions will just be faster and cheaper as on-chain transactions. So how would splicing look like? I mean, I think you understood the idea already. What basically happens is that Alice takes some of the funds from this multi-signature wallet, and she creates a new multi-signature wallet with Alice directly creating a payment channel. And now she can do an atomic multipath transaction to send 3 Bitcoin over to Alice, 0.3 Bitcoin over to Alice. Yeah, as I said, so this is how the multipath transaction looks like. So this is currently my proposal for splicing out and splicing in, just on a very high level. And a disclaimer already, I put it on the last slide, I don't know if it works. Like, I haven't implemented this and tested this. On a sheet of paper, it looks solid to me, but maybe you already find the mistakes and say, Rene, what have you been thinking? So basically what you do is you create a new funding transaction with 2 outputs, which spend from the former funding transaction. One output is the splice amount that goes to some recipient address, and the other, so it can be used even for funding a new payment channel. And the other output is the multi-signature wallet that is currently being used. If you have concerns that your public key might already be on the chain or whatsoever, you have the risk of address reuse, well, just make a new channel there, and you start updating only the new commitment transaction, even if the funding transaction, the second one, is not on the chain yet, right? You only update the other spend. And by protocol contract, just don't update the commitment transaction of the old channel anymore, right? And I mean, either side can just say, I don't give my key anymore, right? And if you do this little thing by just saying, I refuse to do this, or update them accordingly, but I mean, this would be a lot of protocol overhead, so just don't. There's no risk for double spending the initial funding transaction, because when you do this, I can only like broadcast the old commitment transaction, but if at the moment where I created the double spend of the funding transaction, I revealed my revocation key, well, I do a penalty-based system again, and I get all the funds because the other side did something bad, so it shouldn't be a problem. Well, I could also do it by consent and mutual agreement if I want to cancel this placement before the transaction is being mined. It's a technical detail. And yeah, the recipient who receives the spliced out amount should, of course, wait for block confirmation, right? Because only then the recipient knows that the Bitcoin has arrived with them. Splicing in can also work in a non-blocking or asynchronous fashion, in my opinion. So what you do is you basically just create a second payment channel on the same multi-signature wallet, and you can't use it as long as the funding transaction for the is being confirmed. And you just continue using the first channel, and you merge the two channels at the point in time when the second funding transaction is confirmed. So what you do is you update the channel state. You can generate a new pair of commitment transactions that spend both inputs, and the commitment transaction will spend the output of both funding transactions. I mean, of course, the problem is that the spend later, when it really has to be published to the blockchain, is longer because you have two inputs. But, well, guess what? I mean, you have two inputs, right? It's live. And then, of course, when you do this, you invalidate both old pairs of commitment transaction by revealing the revocation keys. And I think that should work. But again, disclaimer, it's not being tested. It's just on a sheet of paper. So maybe I'm mistaking here. Also, it could be nasty to implement this, handling all the several active states. Yeah, while I was thinking about the splicing thing, I came up with this idea of virtual payment channels, which I wrote a blog article about. So what virtual payment channels do is, I think it's interesting for you, I told you before, is they operate on trust instead of the blockchain. Right? And now you will all say, what? Isn't the entire idea of being trustless? Yeah, it is, right? But you know, maybe there are some settings where it might be useful to trust somebody for some gain. Maybe sometimes you already trust someone for reasons that are really reasonable, right? So what would this happen is we have the opportunity to have less funds in a hot wallet, right? Which is an advantage. We have, however, the risk for channel partners that might spend our funds. So Alice can effectively spend Bob's funds and vice versa in a virtual payment channel. However, there is no risk for all the other participants in the network, right? So this entire HTLC thing can basically be there. It can be implemented or it can just be omitted, but routing can take effect. Only the channel is built on trust. What are the applications for this? Well, if you have a central node or hubs, and they might like exceed the hardware capacity because they have so many channels going on. They want to distribute the channel among several computers. Right now, the problem is when you distribute this, you also have to do clearance between all your nodes and have to be able to route payments between them, and you have to allocate more funds. Well, it doesn't really matter. So balance and routing becomes difficult. And so the thing is, it doesn't really matter if I have two nodes and both belong to me, so I trust myself, obviously, if I get a routing request on this one node and the other node just pays it, right? It doesn't get reimbursed, but I don't care because both nodes belong to me, right? No big deal. So I can run several nodes in a virtual payment channel among them. For example, if you have a mining pool, it's another application, and the mining pool wants to do payouts of the funds all the time. What the mining pool can do is it can fund inbound virtual payment channels with its customers. And then the customers, they can use this virtual payment channel to spend the fund by doing this. This will obviously only be useful if the mining pool has some outbound channels to the networks where the funds actually can really go, but it doesn't have to update every day when it does outputs with splicing transactions, the payment channels. And the people who are in this virtual payment channel, they trust the mining pool at this point already because they have the mining contract, they already provide their hash power in order to be able to spend this. So I think there are use cases for this. Yeah. Okay, then there is L2, which again, as I said before, it's another way of invalidating channels with less overhead. It extends the protocol to allow for a new type of channels. There's no need to store all the old revocation keys. You just need to store the newest state of the channel, which is a great improvement. Ascribing blame is not necessary because it's a symmetric information about the channels. And multi-part channels become much easier. So now I can create easily a channel among 3 people or 4 people or 5 people, especially if snore signatures are being included. And I mean, both would happen in the same soft fork of Bitcoin. So the BIP that makes it possible is easier, and also implementations will carry way less overhead. Watchtowers, HTLC, splicing. I think also APM routing. I haven't thought through this yet, but I think also APMs would. I don't see why they wouldn't become easier. I don't see why they wouldn't, quoting Donald Trump. I don't know. Wouldn't. I should be wouldn't. So again, read the paper. It's on blockstream.com and on my blog. And then one last topic, atomic swaps. I will just really briefly. It's kind of a decentralized exchange. Even though I do it only briefly here, it's a really, really cool feature and idea of the Lightning Network. So the Lightning Network can basically be built on top of any blockchain, not only the Bitcoin blockchain. So if a node has a payment channel on top of different blockchains, yes?
Yeah, that's not completely true. So for example, you need to fix the transaction ability.
Sure.
So for example, Bitcoin Cash would be out. Almost. Yeah, they haven't fixed it yet. So.
Yes, so I hope you sold your Bitcoin Cash because they will become worthless. I mean, of course, if I just invent some blockchain that is just doesn't have any useful scripting language, right? So yes, I mean, technically not true, not every blockchain, but most blockchains or many blockchains or Lightning compatible blockchains, but I mean, you can port it to, let's say, many blockchains, right? Yeah, and if a cryptocurrency wants it, they can fork themselves, so the ideas are not particular to Bitcoin, let's say it this way, right? So if a node has channels open on 2 different blockchains, what the node could offer is doing an atomic swap, saying, well, I take a routing payment in of Bitcoin, but I send Ether out or something else. So in this way, acting as a decentralized exchange, maybe taking some fee for doing this, another node at the end of the path could also do it, so the user has not realized that his payment goes from Bitcoin to Ether to Bitcoin and arrives, right? So this gives even more blockchain applications the power to power the Lightning Network if for some reason the network grows so fast that the Bitcoin blockchain still becomes too small for all the transactions to open and change and update and delete channels. So how much throughput can go through the Lightning Network, so it would be great. And I also want to shout out to Jeff from Fulmo Lightning and give him special thanks. He's organizing the Lightning Hack Day. The next one is in Berlin on September 1st. You should really come. I think it's going to be a great event, especially because I think the day before there's going to be a hackathon and there's also a great speaker there. I think Christian Decker from Blockstream is coming and also people from Async. And also, my decision was a little bit easier to go full Lightning development because Fulmo is sponsoring me a little bit for my open source activities. So yeah, thanks to them and yeah, thanks to you. Yeah.
So you mentioned L2 earlier, and there needs to be a soft fork for this initial upload or part of it. Aside from that, what do you think personally is the biggest disadvantage of having L2?
Yeah, so the question was, what is the biggest disadvantage of L2? Yeah, soft fork, yeah, no, but also within the protocol. Honestly, I don't want to do like shameless advertisement, go to my blog and read it up because I just forgot right now. I mean, I gave a really long presentation. There's 2 disadvantages that I named, but I'm currently just having a black box, so yeah, sorry. But at the very bottom, I listed them as pros and cons, so yeah.
The disadvantage is that the punishment that the other side gets all the channel, it's not there anymore. So basically trying to cheat somebody does not cost that much.
Yeah, exactly, that is one, yeah, definitely. So okay.
Instead of overlapping, they are summing up. Something like that, I remember.
Okay. I don't know. Sorry. I mean, I read through it. I was pretty amazed by it. I thought first that one disadvantage is that you need more transactions, on-chain transactions, to close the channel. But I realized it's not true, right? So no, I didn't realize Christian Decker told me. And yeah. Yeah. Okay.
So if I am an online shop,
yeah.
and I'm working on Lightning, and I'm growing, with more growth, I have more payments and transactions. Do I need to open more channels? What is the relationship? Is it like linear, logarithmic, or constant?
Oh, you have to simulate this. I don't know. How should I know? Yeah, repeat the question. So the question was, if I'm an online shop and I get more and more channels, right? How is the benefit for me working if I add more channels? Is this logarithmic, linear, with the amount of channels of more successful routing, or?
No, yeah, for successful routing, if I have more and more transactions, do I need more channels, or will kind of have to care?
Well, so the thing is, I mean, within one channel, there's some numbers flowing around that a channel can probably do something like 500 transactions per second, right? So obviously, if you want to do more transactions, you need more channels. Also, it's not quite clear if all transactions really go through this one channel, right? Because the hash time lock contracts bind at least some funds of the channel, and it could be many, and they could not settle at the end. The thing is, when I played Lightning tennis with a friend, right? So what we did is, we just created a shell script where we asked the other party for an invoice and then did this concurrently and sending money back and forth. We basically did something like 40 transactions per second, right? We're not in the same data center, right? But in Germany, both nodes, right? So I would say we have to really benchmark how much throughput we get through the network or through one channel, right? But then on the other side, I mean, how much transactions do you want to do as a shop within 1 second? I mean,
it's also that I'm discoverable in the network.
Yeah.
So that's my question. If I'm growing and a lot of nodes or payments from all over the world, do I have to get more channels to be discoverable? Or?
No, probably not. So also again a question of topology, right? And we don't know the topology. but I would say that it is a reasonable assumption that the Lightning Network topology resembles to some degree the topology of a social network, right? And if you know what the topology of social networks looks like, well, you know, 150 channels are probably enough to know everyone in the world over 5 hops, you know? It's this Dunbar number or whoever, Milgram, yeah. So I go in this direction, yeah.
So if you look at everything you want the Lightning Network to be and all the problems that you're seeing on the way, what are the odds that you think you're going to achieve what you are starting now, what you want to have in the end? And is there even a chance with all the problems popping up that you can achieve that?
Okay, so the question was, if you look at all the problems and all that you want, what would be the chance that you achieve this at some point in time? Like, not me, like you as a community, I would assume, right? Because I alone couldn't do it, right, to be quite frankly. So I'm very optimistic, honestly. If you look at this, how such a few group of people already provided this great prototype, and most of the features that we want are at least conceptually solved, I would say. Give us 2 years, maybe 3, I don't know. Maybe fast coders or more people jump in, right? But I mean, more people doesn't make it automatically better because it's more discussion also, right? So I would say I'm very optimistic on this. I think it's conceptually clear. It's no hard problems in the sense of like unsolved problems. You know, I'm a mathematician by training, right? So for me, a hard problem is the Riemann conjecture, right? Nothing like this involved. So I think the hardest problem is the topology thing. But when I realized that splicing would be possible, I would say it's not so important anymore, right? And even with virtual payment channels, you can do shortcuts. And I would say there's many parties trusting each other's, providing liquidity to the entire network. So, yeah, you know, I'm not a future teller. Recently, someone asked me if I could do an interview. How will the Lightning Network transfer the life of people in 2030? I'm like, yeah, it's a great interview. I just don't do it because, you know, it's like, yeah.
So coming back to the initial statement, so do you think a fee market will emerge within the Lightning Network or not?
Okay, so will a fee market emerge in the Lightning Network? It's really funny. I was for I can't say years, but for months, I thought it wouldn't, right? Because if you, from an economical perspective, look at this, the marginal cost for doing such a payment, there are 0. Basically, in the first thing, what you think, right? So you open a payment channel, and afterwards you can reuse it all the time, all the time, all the time. The thing is, it's not quite true, because you cannot open arbitrary many payment channels, because only a certain amount of transactions fit in the blockchain, right? So there might be the fact that the fees in the Lightning Network, the Lightning Network can decide, well, I can agree to a certain fee level, because otherwise, you just go to the blockchain, right? So that you rather use the Lightning Network. The second thing is, there was today this like really weird and I would say stupid discussion, and I will repeat it now. So there was this guy who created all those channels, and he had this blog article written, and then he was like, yeah, I routed 260 transactions, and I made like 0.12 cents for every transaction. So it's like 30 cents that I have earned right now. And if you look at my hosting costs at Amazon Cloud, this does not even work. So Lightning Net. Yeah, right. And he was like, so the Lightning Network is like, to earn money, it's stupid, right? And therefore, no one will use it because no one will provide funds because they're going to do mining, and kind of like Bitcoin Cash is better, you know? And I was looking at this like, okay, framing. First of all, what you were saying, right? First thing is, well, it's a proof of concept. The fees are cheap. But then do the second calculation. 0.12 cents. 40,000 transactions, Visa processing per second, $48 per second. Well, that's $4.1 million per day. That's quite lucrative, I would say, with a reasonable cheap fee. And then the fee currently is based on the Bitcoin price. If the Lightning Network explodes, the Bitcoin price will explode, right? So this amount even gets higher because it's the amount of Satoshis that you get, right? So this made me change my mind a little bit of really calculating this through and saying, well, if you think about it, it's actually quite reasonable to operate this.
Everybody thinks like that you want to earn some fees by routing.
Yeah.
They will also raise their
Yeah, but then I could come in and say I'm a discounter and I do it cheaper, right? Because it's lucrative, right? So there will be some game theory, but the thing is the market entering barriers for operating a Lightning node right now might be a little bit difficult, but they are forever much, much easier than running your Bitcoin mining operation. I mean, be serious, right? You don't need to spend like millions of dollars in hardware or whatsoever, right? I mean, you just open up your node. Basically. Yeah.
I would also add, you don't need to run your node on AWS. That's actually really expensive.
Yeah.
You can buy like an Odroid for $60.
Yeah.
You know what I mean?
Yeah, so the comment was you don't need to run your Lightning node on AWS. It's expensive. You can do it on something cheaper. It's true, yeah. I mean, maybe it cannot handle as many channels, right? And then you have to wonder what is the best hardware. And, you know, I mean, there's probably a lot of optimization problems going on there. But honestly, people, I mean, I understand that many people here might be motivated by the fact that this thing is gaining traction and that we're getting money. And honestly, I would probably also not standing here if after I made my first Bitcoin investment, Bitcoin just was a nice idea that didn't work, right? But please don't focus so much on this earning money thing. It's a financial revolution that's taking place. It's incredible what's going on, right? Just create your node. Yeah, but as I said, I mean, there is some bottleneck with the blockchain, right? So there will be some interaction. Yeah, exactly, right. Yeah.
Just to recap this really quick, because you explained Bitcoin transactions in the beginning, and then you started to explain Lightning transactions in detail, which was pretty good. Which I was actually nitpicking in the first half. You named what it is in ICO and so on, but you did not name what it is. This is a second layer solution.
Okay.
There was this one slide that was missing, and I think what you're actually getting at. Of course, Lightning will have a new fee market and so on, but why do we actually get to the point to develop Lightning and so on? Because on the Bitcoin protocol level, we haven't had the chance to do this because we are stagnant at some point. We have the megabyte limit. You can recap shortly if you want why the Lightning network come to place, but it was because the Bitcoin protocol itself can't handle so many transactions.
Sure. Yeah, so the comment by the audience is basically to sum up. Yeah. So the comment by the member from the audience basically was.
Perfect, but that's where we come from.
Yeah, so the comment basically was that Lightning is the second layer solution, which by the way was a little bit in the slide when I compared it to internet. Tiny there. And so it came because the fee market from Bitcoin was there and was messed up and so on. But I mean, that's at least my frame that I'm currently having. Lightning Network is Bitcoin, right? We're just using Bitcoin. It's Bitcoin transactions. We just decide not to broadcast them. Some weird contracts that we write into them. Maybe we find even better scripts that we can write into them, right? So I was about to actually have a different name for the talk of saying, and Bitcoin does scale after all, right? Because it does. We see it, right? The Lightning Network scales. The question is, will people use it? Will it work, right? It's a different question. Theoretically, it does scale. Yes?
Thinking about the long term of this, would you be at all worried about the scenario happening where transaction fees get so high that creating and closing channels is only a very high level feature that normal people can't touch? And that there's a separate, that Lightning Bitcoin are not the same as normal Bitcoin then, that they might be traded separately, like as Lightning Bitcoin would be worth less than normal Bitcoin.
So the question was for the viewers on the internet, hi internet, by the way. So the question was, am I worried that the Bitcoin fees become so high that opening Lightning channels won't work anymore and the network kind of like, not for normal people, yeah. So yes, I mean, you can calculate this through, right? You can do roughly, let's say, 1 million Bitcoin transactions per day if you're really good, right? And so we have 3 or 4 billion people using the internet currently. If they're all supposed to go on Lightning, it's going to take a while until everyone has at least one payment channel. And with everyone having one payment channel, we don't do so much fun yet. So yes, there are problems, right? There's different answers to these problems. So, I mean, you can still change the Bitcoin protocol a little bit. For example, also if you have L2 and you have multi-part channels, you can have channels among groups of people and so on and so forth. You can even have some stuff like putting custodians into the channels. So you can have semi-trusted channels, you can have these virtual payment channels which could resolve the problem, right? So the question is really later on, like with TCP/IP nowadays, you don't really realize that you're using it, right? So I think what we don't know and what we can't predict currently is who by the end of the day is actually really using the Lightning Network. It could be very well that for some reason I have some contract that is working on some other technology maybe even a legal contract, that only a few people giving access to the Lightning Network, it still solves many problems. But I mean, of course, the best case, or the case we're all dreaming of, is that everyone has their own Lightning node at home and have that running, right? So yeah, it scales much better, but it doesn't scale like infinitely right now. But it scales, I would say, far enough. Yeah.
I would also add, if that's the case, like we've already overtaken Visa, you know.
Yeah.
Like we've already won. Like, you know, so that's a happy thought. You know what I mean? I love that sentence. Well, because
Yeah. So let me answer this maybe on the phone, because then I don't have to repeat this on the microphone. So because I mean, there's many arguments to this question because it comes up. So his argument was, if this really comes into place, it's already that big, so it's a happy problem, right? We're already as big as Visa, maybe not quite as big, but big enough, right? So yeah, and so for me, I would say the fact that you can do it later on top of multiple blockchains, that's a pretty good thing, right? Because then it scales horizontally. Yeah, I think there was another question first, right? Okay. Then.
Before you had flight of your proposal regarding hardware wallets for the protection of the node.
Watchtowers.
No, hardware wallet for the nodes.
Yeah.
Because of the problem that a node is not wallet.
Yeah.
And so by blinding the address, maybe you can do something with hardware wallet. That was your proposal, because you skip the
Yeah, let's talk to this bilaterally, because it's a very small idea, and while I was doing the slides, I decided to put it in, and yeah, let's do it later on. Yeah. Okay, so I guess yeah.
This may not be thought through to the end, I'm just asking. I still need to learn. But do you think that atomic swaps and Lightning channel settlements on the Bitcoin protocol can create an arbitrage market problem?
Yeah, they will. So I mean, as I said right now, routing fees, right? When you forward an HTLC, you take a little bit of the output for yourself, right? And that's already a market, even though it's a very small fee. If you look at the arbitrage market that already exists, it's crazy.
Because it's a worldwide currency, and it's digital, and it's instant.
So I mean, it's always being compared, the Lightning Network with the internet, right? There is a huge difference between the two, right? When I'm a router on the internet and I'm on two different link layer protocols, I don't mind. Right? I forward every traffic in every direction as long as the link layer protocol supports this. With Lightning, it's a little bit different, because every time I forward something, the topology changes. And then, of course, if it's two different blockchains, I have to see what's the current value, probably different at different exchanges. Well, exchanges, how they operate currently, will probably change to be on the Lightning Network. But, I mean, exchanging this information...
For exchanges as well.
Yeah.
Payment channels are getting filled.
Yeah, but again, I mean, if I see already how many people are trying to create their startup luring on these atomic swap payment channels, I encourage each and one of them to do 1 year of protocol development, because then you understand the protocol so much better that you can do the much better exchange after all, right? So maybe I'm also luring for the exchange, I don't know. Yeah, no, so yeah, it's, yeah.
And everybody's going to be so smart, and it's going to be so fast that if one Satoshi earned is more than the processing power you spend in NSE conjunction, somebody is going to do it.
Sure.
You maybe have like 2 years or 5 years or 10 years to earn some money and something like that, which doesn't make sense to me. But at the end, it's just gonna even out, and the processing power is gonna be what in energy is gonna be in Satoshi. So it's just gonna balance out on one baseline.
Yeah, so maybe to sum this up, I think there's huge opportunities to be creative and create smart business models on top of Lightning. I think much smarter models than creating decentralized exchanges and routing and all of that, but it's all watchtowers. But the thing is, currently we need to develop the protocol first, right? Because if the protocol is not stable, we can think so much as we want about all these things. So my biggest fear maybe is that now people all start to be very keen on this because the Bitcoin community has a high wish on the Lightning network, right? Bullishness, yes, exactly. Then they all try this out and they're like, yeah, it doesn't work, right? And then in 2 years when it would work, they're like, yeah, I tried this out before, it doesn't work, right? So that's my biggest fear actually. So please, let's develop the protocol. But I'm repeating myself. Yes, Mark. So in the channel, you can almost at most do 1/6 of a Bitcoin unless you change some stuff, I think even in the source code. Don't even think in the configuration. In the entire Lightning network, so I think it was all the time about 30 Bitcoin, and then this shitcoin dude came and he doubled it basically. So I don't know where we are. I don't even care.